Hello everyone, I am Priyanka Verma and this video is in continuation to my previous video for controller area network for beginners, and in this video we'll cover the below topics: bitwise arbitration or how the data transmission takes place, non-return to zero encoding, bit stuffing, and the various topologies that CAN network can follow, and various applications. So firstly, we'll see bitwise arbitration. So as we have heard in previous video, it has two bus states, dominant and recessive. Dominant is 0, recessive is 1. So when multiple transmitters send their respective states onto the bus at the same time, the dominant state must always win over the recessive. Essentially, CAN transceivers employ open collector or open emitter logic to satisfy this rule. So let's understand it better with the help of an example. So here in this particular diagram, we see here that two nodes, node A and node B, are trying to send their data at the same time onto the CAN bus. So here we'll see how one of them wins and what are the rules for that. So the first thing is lower valued identifiers always have higher priority. So the check is going to happen bitwise. So firstly, there'll be a check on first bit, which are same, second bit, which are again same, then third bit, then fourth bit, until there is a difference. So here we see in this particular bit of the identifier, there is a difference. Node A is sending 0 and node B is sending 1. So as we said earlier, the lower value identifiers have a higher priority and the dominant is 0. So node A wins this. Node B loses the arbitration. So node B will re-request the message for later transmission. So here as we see, after the first recessive bit was sent by node B, it stopped transmitting. The data which was supposed to be sent by node A will be there on the CAN bus. This is how the arbitration will take place. So now comes non-return to zero encoding. So here the binary signals to be transmitted are mapped directly. What it means, like, firstly 0 is low, 1 is high. So if the bus is at 0, it will be in sync with that. It will be 0 here and then 1 here, and then it will stay for however bits are of same polarity, and then again the state changes. The signal is constant for one whole bit time, and only one time segment is needed to represent one bit. So if there are no edges, for example, if the data stays for a very long time to like 1 1 1 1 1 1 1, there will be no edges and the receiver will lose the track of the bits, like how many times it was 1 and how many times it was 0 in a row. So for this purpose, bit stuffing is used to ensure the synchronization of all bus nodes. So bit stuffing is like we see in the next, bit stuffing. So bit stuffing is, as we see here in the image, after every 5 bits of the same polarity, a bit of opposite polarity is inserted. This is bit stuffing. And then these stuffed bits are de-stuffed by the receiver. But there are exceptions, like as we saw in the first video, that there are delimiters with 6 consecutive recessive bits, like 1 1 1 1 1. So it won't change that, because that's how the rule is. The delimiters are supposed to be recessive, and this has to be in continuation for like 6 bits. So that is an exception, that won't change. This rule applies for the data. But it's like, but why do we need bit stuffing? As we saw earlier, it is to ensure the transitions, to maintain the sync. So what's happening here? Let's see in this example. So here we are having like more than 5 bits of like 1 1 1, that is the same polarity. So after that, the bit of opposite polarity will be 0. So it will be a 0 will be inserted here. Similarly, after these 5 bits were seen, a bit of opposite polarity here, and then again bit of same polarity after 5, again there was a bit of opposite polarity inserted. But then at the receiver end, receiver destuffs all the extras or the stuffed bits and receives the original message. So what are the different topologies that can follow? Like any other network, the can follow bus topology, star topology, loops, or the combination can be there also. And the next one is various applications. See, there are a wide number of applications for controller area network. As we see and we already know, it's used for automotive, which includes passenger vehicles, cars, for example, trucks, buses, and it's also used in aviation, like in helicopter, in flights, in the airplane, and industrial automation, mechanical control, and lots of medical instruments and equipment also uses CAN protocol. So here I'll close this video, and if anything at all is if you have any questions, you can please post your questions in the comment section. I'll be very happy to answer your questions, and I'm open to the suggestions as well as what more topics I can add to my video, and what else would you like to hear on related to automotive industry or CAN protocol. So I'll be happy to help you if I can. Thank you very much for patiently listening to me.